Hi, class. So it is good to be back. Good to see you again, sort of. We're going to finish up our unit on bridges this week by looking at the materials that bridges are made out of. So this picture is actually of a real bridge in Malaysia. And so we're going to talk about what it's made of and why it looks the way it does. Um, Here's another bridge in Vietnam that no one put in their favorites bridges slideshow that I thought was interesting because I absolutely love this bridge. This is a pedestrian bridge in Vietnam. I have quite a few views of it here. Read a little bit about the architect and artist that created it, and like the moss on the hands is something that they wanted to be there to add to the effect of the bridge, but I think it's super cool. Here's another bridge that I was looking for bridges in movies, and I thought this was from Lord of the Rings, but it's actually a real bridge in Germany. Very cool looking bridge made of stone. So for a while, stone bridges were the main type of bridges along with wood. This is actually a suspension pedestrian bridge in Mount Rainier, and I've actually hiked on this bridge. I took my daughter across when she was probably like 3 years old, 4 years old, and I'm a little bit terrified of heights. So I didn't really want to go across, but she was like all ready. And if we wanted to continue our hike, we had to go. So being a suspension bridge, it means when you get out in the middle, it sways back and forth like crazy. And so we got out to the middle, and she sort of got nervous and started crying. And being a mother, I couldn't cry with her. I had to say it was okay, even though I was about ready to scream and tell her we were going to die. But we didn't die. We crossed the bridge. It's a very cool bridge in Mount Rainier that I want to go back and hike on someday. So here's a picture of that bridge again. It's called a living bridge because what the people in Malaysia do and have done for this bridge is they train trees, swamp trees, to cross the river, and their actual growth creates the bridge. Now, this is a pretty smart material for this area because it's a very, very high rainfall, high humidity area, and any bridge made of just wood would rot, and they don't have access to steel bridges or ways to actually get it into the area. So what you see here are natural bridges that only get stronger and stronger with each year as the roots actually grow together. So I think it's a pretty cool bridge. Here's a short little movie clip of a bridge material. So let's watch that. Here he is going across a bridge. I don't know if you've seen this movie Onward, um, but there's quite a few movies that use the same idea of a bridge that you can't see. Uh, so I was not able to find a real bridge that used this type of material, but I just thought it certainly would be very cool if we could make a bridge that actually looked like that. Um, So here is a bridge in Portland made of pretty much all steel. And so today we are going to start looking at materials. We will finish up materials and bridges this week and go on to natural bridges and earth science. I want to do a little bit of history and education of steel. We take it for granted. It's everywhere, but most people have no clue what it actually is. So here's another picture of just a steel bridge. We use them for trusses. We use them for the roadbed sometimes. We often use a combination of things, but a lot of times the trusses themselves are made of steel. So way back, a long time ago, metals have been used for thousands of years. But for a long time, the only metals we really used during the Bronze Age were gold and bronze. These were the only metals we could really find in the earth. So both of those, I'm sorry, gold and copper and bronze. We'll find out what bronze is in a minute. It's an alloy. Uh, so Metals are special because they are malleable. So what that means is that you can hammer them into new shapes without breaking them. So when you strike them with a hammer, they don't break. You can actually sharpen a knife that way and you can make new shapes. And at the same time, they can be melted and made to flow. So malleability is this idea that you could take something like a chunk of metal and hammer it into a sheet of metal. And so that's a very unique property of metals. The science of metals is called metallurgy, and it has been around forever. For a very long time, we didn't necessarily understand the chemistry behind metals, but it was more of a craft, meaning it was an art that people passed down from one generation to another. So actually, metals are types of crystals. This is an amethyst crystal, and so you can tell that it's a crystal by looking at it because the atoms join together to make one large crystal in a repeating pattern. Plus, it's kind of see-through. Here's diamonds. Diamonds are a type of crystal, and the reason they're considered so beautiful is just how reflective they are and the number of planes in the crystal that reflect light. But metals are also crystals. They have repeating patterns. So these pictures show, if these were the atoms, show a repeating pattern inside a metal. And one thing we need to know about metals is this word's up here, dislocations. So dislocations are what allow us to bend and mold metals, because what they do is allow us to actually rearrange this pattern. If you try to rearrange the pattern of a glass, so like here I have a glass jar, paintbrushes. I've been painting in our spring break. I'll show you some of my paintings later. So if I try to hammer this and rearrange those atoms pattern, it will simply shatter. But a metal has what you call dislocations so that you actually can rearrange them, and it's what makes the metal be able to bend. Now, one cool thing that I love about physics is it does make me see the world in a new way, all sorts of things. So I want to introduce you to the paperclip, something we use all the time, staples too, but have you really thought about them? So here's a paperclip. It says you don't need to use a hammer to experience the power of dislocations. When you bend a paperclip, it is in fact the metal crystals that are bending. If they didn't bend, the paperclip would be brittle and snap like a stick. This plastic behavior is achieved by the dislocations moving within the crystal. Remember, the crystal of the metal. As they move, they transfer small bits of materials from one side of the crystal to the other. They do this at the speed of sound. As you bend a paperclip, you're causing approximately all these numbers. So that's, let's see, 100 million trillion, 100 trillion dislocations to move at the speed of 100 of meters per second. Although each one moves only a tiny bit of the crystal, one atomic plane in fact, there are enough of them to allow the crystal to behave like a super strong plastic rather than a brittle rock. So this is from a book called Stuff Matters. And I am actually basing this lecture off of stuff I learned from this book. It's a great book. It's sciencey, but it's written in a way that's very entertaining. So one thing to know about metals is they can be melted. And the melting point of a metal is actually an indicator of how tightly the metal atoms are stuck together and how easy it is to move those dislocations. So if the melting temperature is really high, like tungsten, it means it's going to be very brittle, not necessarily strong, very brittle metal, because what happens is those dislocations are unable to move. So that's how melting point is related. Now, this is a picture of elemental copper. So it was taken from the earth. And so copper is one of the metals that we could just find on the surface of the earth. Not all metals can you actually find on the surface of the earth. But the cool thing is, for a long time, the only metals we really had uh, were very limited. So then they found out that malachite, this is a picture of malachite. So malachite, when put in an oven with lots of red hot embers, and you put it in the oven and heat it up to very, very high temperatures, you end up with copper. And so just sort of one way that copper began to be used. So even from around 5000 BC, early metalsmith used copper and trial and error in order to make the metals. So even the pyramids in Egypt, the way they were built were by using copper chisels. So these are the chisels, and it said that over 300,000 chisels were used to make the pyramids. Without those chisels, they could not have made these gigantic historic structures. Um, an alloy. Okay, so a lot of metals are soft, including gold. Gold is a very soft metal. So an alloy is when they take a metal and combine it with a different type of metal, and it gives it new properties. And what it does is it makes dislocations, like in gold. Remember, those dislocations are where the pattern is disrupted. So what the alloy does is it puts in a different type of metal. So, for example, chromium or silver to make the metal stronger, to make the gold stronger, and it makes it harder for those dislocations to occur. So we discovered alloys, and alloys made it where we could make more useful metals. So here's two alloys. So one of these, this is sapphire, a sapphire crystal, and this is ruby crystals. They are both made from the same substance, aluminum oxide, a metal, and it's colorless and not very pretty. But when it is combined with iron in an alloy, it makes this blue sapphire, and when it's combined with chromium impurities, it makes a red ruby. Now, alloys are not a chemical change. They are kind of like a mixture, but they are mixed in together and change the property of the substance. So the Iron Age, we made stronger and stronger alloys. So copper, it was the material we used a lot, but we could add copper and make an alloy of it through smelting to make bronze. And bronze is simply copper added together with tin. And so we made many things that were stronger out of bronze. So then that brings me to steel. So this is steel. So steel, every year when I teach chemistry, students look for steel on the periodic table. Steel is not an element. You can find copper on the periodic table. You can find aluminum. You can find tin, but steel is an alloy, and it is made from iron and also carbon. And the carbon they were able to add to the iron just by this process of, like, when you burn wood, you end up with lots and lots of carbon. So the carbon was snuck into the iron and it made steel. Now, this is the Excalibur sword, if you've ever heard of that. Swords were made of steel, but the problem was that if you put too much carbon into the iron, then your steel is very brittle. So it was very common for swords to actually break in battle. So, like, if you have 4% carbon, that's too much, and it's going to be brittle and break. But if you have no carbon at all, then it's going to be too soft and just iron. And so about 1% carbon seems to be a magic formula, but they didn't know chemistry back then. So it was all, again, a craft. Sword forging and making swords was a craft passed down as an art. So the Japanese samurai sword was about the best sword known to man for about 500 years running till into the 19th century. And they had a process of making the sword out of steel, where the inside of steel was more flexible and the outside steel was the more hard, brittle steel, so it could be sharper. And they made strong, sharp swords that did not break in battle. Then the Industrial Revolution came, and we started to make larger and larger items out of iron and steel. And so this is one of the worst accidents that happened in Scotland, where they made, it's called the Tay Rail Bridge, and it collapsed in 1879, killing 75 people in the process. So then there was a scientist who discovered a way other than just forging it in from trial and error, discovered a way to add this carbon to the steel. And he actually figured out a way of taking the carbon out by combining it and making carbon monoxide, taking it all out, and then putting back in about 1%. And this revolutionized the amount we could use steel. Uh, Stainless steel was a brand new discovery because the problem with steel is it rusts. When steel is exposed to water and air, it forms rust or iron oxide. And so that totally changes the metal into something new, and it is no longer strong. So stainless steel was discovered. And here is a sculpture. This sculpture is called the Cloud Gate in Chicago, and it's made all of stainless steel. So bridges that you see are generally not made of stainless steel. So you might wonder why, because they do rust. So here is a picture of a metal in its rusted state. So for today's assignment, we're just going to do a small amount of research about metals and their uses and steel. I hope you learned something.